Does the meaning that the electrical resistance is zero also mean that the orbit of the electron is constant? No, having zero electrical resistance does not imply a constant electron orbit. No, having zero electrical resistance means there is no resistance to the flow of electric current. On the other hand, a constant electron orbit means the path of the electron remains unchanged. These two concepts are completely unrelated, and there is no direct relationship between electrical resistance and electron orbits. When does resistance arise? What happens when electrons collide with atoms? Yes, electrical resistance occurs when electrons move within a material and interact with atoms or molecules. During their movement, electrons collide with atoms, resulting in energy consumption and interference with their motion. This energy dissipation and interference lead to the resistance to the flow of current. Therefore, electrical resistance is related to the interaction between electrons and atoms. If electrons can move without colliding with atoms, protons, or neutrons within the material, then there is no resistance. This state is called superconductivity. Superconductivity occurs at extremely low temperatures and allows for the flow of current without any resistance. Superconductors are highly efficient for electrical transmission and are used as such in specialized applications. However, this resistance-free state is limited to very low temperatures, and at typical temperatures, the interaction between electrons and atoms leads to resistance, resulting in power losses in conventional electrical transmission systems. Then, if the arrangement of atoms at that time is irregular, it can be said that resistance is generated. That's correct. When the atomic arrangement is irregular, electrons find it difficult to move freely within the material. This irregular arrangement increases the probability of electron collisions, leading to the generation of electrical resistance. Irregular atomic arrangements commonly occur in rocks or amorphous materials. In contrast, crystalline materials have regular atomic arrangements, making it easier for electrons to move freely and resulting in lower resistance. Hence, an irregular atomic arrangement becomes one of the factors that hinder the movement of electrons and increase electrical resistance. As a result, materials with irregular structures may exhibit electrical instability or high resistance characteristics. Is there movement of electrons when a substance is in a solid state? Yes, even in the solid state, there is the movement of electrons. In a solid, atoms and molecules vibrate, and electrons are also free to move around these atoms or ions. This movement of electrons is known as electric current. The movement of electrons in a solid is related to its electrical properties. Generally, materials like metals have freely moving electrons and exhibit excellent electrical conductivity. Such materials are called conductors. On the other hand, some solid materials restrict or have very low electron mobility, making them electrically insulating or unstable. These materials are known as insulators. However, most solids allow the movement of electrons, so they possess electrical characteristics. In summary, in the solid state, electrons can move freely, and their movement contributes to the electrical properties of the material.